Hello everyone, welcome to SolveStream. In this video, let's evaluate all 6 trigonometric ratios of 30 degrees using one simple triangle. Follow along as we break this down clearly and visually. For this, let us consider a triangle, an equilateral triangle to be specific, where each side length is 2 units. So this is 2 units. Let's label the other sides as well. 2 units here and 2 units here. Now since it is an equilateral triangle, all the angles would be 60 degree each. So this is 60 and this is also 60 degree. Now the next step is to drop a perpendicular from the top vertex. Now this divides the equilateral triangle into 2 right angle triangles, where it forms a 90 degree angle here and a 90 degree angle here. And the baseline, which is 2 units, will be divided exactly into 2 halves, where each one will have 1 unit each. So this is 1 unit and this is also 1 unit. Now there are 2 right angles triangles now, and let's talk about the angle. The 60 degree angle will also be split into 30 degrees each. Now to avoid confusion, let us erase this triangle, a right angle triangle, so that we have only one right angle triangle and it will be easy for us to work on it. Now we have a right angle triangle. Let us start the trigonometric ratios now. Let's start with sine 30 degrees. Now we know it is equal to opposite by hypotenuse, where the opposite side here is 1 over the hypotenuse is 2. So the sine 30 is 1/2. Let's do cos 30, and it is found by adjacent over hypotenuse. Now if you observe the right angle triangle, we don't have the adjacent side here, so we will find that out using the Pythagoras equation. The Pythagoras equation is given by a square plus b square equals c square. Now here we know that a square is 1 square, so let's substitute that, plus b square, which is the adjacent side, equals the hypotenuse, which is 2 square. From this, b square equals 2 square is 4, so 4, if I bring that 1 here, it will be minus 1. So b square will be equal to 3, and it gives b as root 3. Now we have the adjacent side as root 3 units. Now let's substitute that in cos 30, where it adjacent by hypotenuse. The adjacent side is root 3 over hypotenuse, which is 2. And we've got the value of cos 30 as root 3 over 2. Now let's do tan 30. And tan 30 is given by opposite over adjacent. Now we know the opposite side is 1 and the adjacent side is root 3. So the tan 30 degree is 1 over root 3. Now since we have got these 3 trigonometric ratios, it is easy for us to calculate the other 3, which are just the reciprocal identities. Let's start with cosec. Cosecant 30 is the reciprocal of sine, so it will be equal to 2 over 1, which is equal to 2. Now the other one is secant 30, and we know this is the reciprocal of cos 30, which will be equal to, now this will be the reciprocal of root 3 over 2. Now we have secant 30 as 2 over root 3. Now tan 30 and the reciprocal of it is cot 30. So we can easily find out cot 30 by doing the reciprocal of tan 30. Now with this is equal to, now tan 30 is 1 over root 3. So cot 30 would be equal to root 3 over 1, which can be written as root 3. Now since we are done with finding all the trigonometric ratios with 30 degrees angle, now let's take a problem based on this. So the question is, a ladder resting against a wall makes an angle 30 degrees with the ground. The length of the ladder is 10 meters. You have to find the height of the wall where the ladder touches it. So based on this, we'll draw a figure first. So let this be the ladder, and the length of the ladder is given to be 10 meters. And it is also given that it makes 30 degree angle with the ground. Now you have to find the height of the wall, that is this. So let us take it as h. Now the trigonometric ratio that is used here would be 30. Sine 30 equals opposite by hypotenuse. Now here the opposite side is the height, which is h, divided by the hypotenuse, which is 10. And we know that sine 30 is half. So from this, h will be equal to 10 over 2, which is equal to 5 meters. So the height of the wall is 5 meters. Now it is important to understand that we are using sine 30 here because the height is the opposite side of the angle. So the opposite and the hypotenuse, both the ratios are used in sine only. So that's the reason we are using sine 30 here. Now that you have learned how to evaluate all 6 trigonometric ratios of 30 degrees, it's time to put that knowledge into practice. I have prepared a helpful worksheet with guided steps and practice questions to reinforce what you have learned today. If this video helped you, make sure to give it a thumbs up and subscribe to SolveStream for more clear and easy explanations.